All right. Okay, and we should be good to go.
We're going to get started shortly. We're now.
Yep, we're ready. We are live on the air. All right, thanks everybody for coming. This is, I think, one of the larger crowds we've had. I'm really happy to see everybody out here. I am, specifically Dominic Canary. Right. We are devICT, community for developers, designers. We try to be accepting for users of any language, framework, operating system. We recently were inspired to come up with a mission statement. So it is to educate, empower, and connect software developers in the Wichita area and beyond. Please silence any pagers or cellular devices. I'm going to go through a list of ways that you can be involved in devICT if you're at all interested. The best way, and I always put this first, is to chat with us daily on IRC, the Internet Relay Chat. This is chatting for hackers. We're on Freenode. The channel is #devICT. If you don't want to install a command line, an actual chat client on your machine, we have one on our website, devict.org/IRC.
Hopefully it works better than this afternoon.
There was some problems this afternoon. You can also watch past presentations. All of our talks are recorded, and we post the videos up on our website, devict.org. We also have some code challenges on there. We haven't really been staying on top of those, but maybe we'll put some steam into those someday. Another way to be involved is to donate. Our membership in this group is free, and we're planning to always keep it that way. Donations are appreciated because we do have monthly costs. Up to $150. I think right now it's like $100. But we pay for the meetup group. We may be paying to stream the presentations using a different service. We have hosting for our sites, and then we have our membership at the Labor Party here that allows us to do these events once a month and kind of whatever as needed. There's a PayPal donate button on devict.org. Talking about the Labor Party. This place, if you haven't been here before, is a co-working space for just if you might work from home, you might choose to work here instead just to be around other professionals. I know, maybe I shouldn't say on here, I can't work from home. It doesn't work out in my family situation with my 2 little ones. So if I would work from home, I would work from here instead. So I was saying vacancies are available. Another way to be involved is to give a talk. We're always looking for people to sign up to give a presentation on any development-related topic because we are a general group. And giving a talk on a topic is actually a really great way for you to learn in depth about that topic. If you feel like there's something that you like, you're interested in, and you know a good deal about it, and you want to give a talk about it, if you're like me, when you're preparing for that talk, you're going to learn a lot. And like I said, any development design subject is appropriate. And if you have aspirations of maybe presenting at a professional conference someday, presenting at a user group is usually recommended to work on these presentation skills, but also to work out the kinks and the bugs in your talks, so that then you can submit them to conferences and try to give them at one of those. Another way to be involved, No, we're trying to be pretty friendly. Another way to be involved is to work on. We did have a guy from the Netherlands present at one time.
He didn't come here.
He presented remotely. It was like 3 a.m. his time when he did it.
No, it was middle.
Right. So startupwichita.com is a project that we've been working on as a group when we have time. It's in the mean stack, so MongoDB, Node.js, Angular. It's a project if you're at all interested to be involved. There's another site that we just threw together real quick, jobs.devict.org, where people will post job openings. If you have a job opening at your company, post it on there. If you're looking for a job, just go give it a look. Okay, enough about being involved. Upcoming events. Women Who Code, which is another group in Wichita. is having their hack night Wednesday, September 3rd, at Baseline Creative, which is First and Hillside, I think. They have a Groupon meetup, and that has the actual address on there. I know there's a small group, at maybe a caravan at this point, who's going down to Oklahoma City October 9th for the Thunder Plains Conference. It's a one-day conference, which is great, because you don't have to get a hotel room, you don't have to commit to like a whole weekend. You meet the whole day, because you got to drive there, have the conference, drive back. But it seems like it'd be a lot of fun. It's focused on HTML5, CSS, JavaScript, APIs, mobile development. And I'm sure there's still room in the car for whoever's driving. We also have a tradition of the day after our monthly meeting, we do a developer lunch. So tomorrow we'll be having lunch at Who Hot Mongolian Grill, which is at like 21st and Rock up there. We usually meet at 11. We try to get there at about 11:30 to beat the lunch rush. If you can show up a little later too, that's fine. We have a weekly event every Thursday morning at 7 a.m., Code and Coffee. The point of this is to have a chance to work on something before you go to actual work. 7 a.m. is pretty early for a lot of people, and that's understandable. If you show up at 8, you'll still probably have a good time because there's usually somebody here till like 10. And yeah, that's here at the Labor Party.
You said before you go to actual work, you mean before you go to the place where you hang out on IRC all day?
Yes. Yeah, if you're being involved. So for upcoming talks, we have next month, Jim Rice, it'll be the last Thursday, so September 25th, Jim Rice is going to be doing a talk on accessibility concerns in websites. And your talk tonight is Rob Johnson talking on test-driven development. So I'm going to go ahead and hand it on over to Rob. There you go.
All right. Okay. Thanks, everybody, for coming. This is test-driven development. I came here to a meeting 2 months ago, and whoops. Where's the microphone on this, by the way?
I'm not sure. It's
okay.
About picking the voice does.
All right.
As long as you're standing in front of the laptop, you should be good.
Okay. If you hear anybody sending a message saying they can't hear me, let me know.
Okay.
Okay. So 2 months ago, I came here and saw Jacob give a presentation on object-oriented development, and it was a really good presentation. And Seth said, if you have any ideas for a presentation, feel free. So I said maybe we could talk about test-driven development. So we're here. So since we all get tired of writing, long names, we like to abbreviate things. So TDD stands for test-driven development. Is it just a buzzword? Let me, before I start, get an idea. How many people have practiced test-driven development in their? Oh gosh. Okay. Okay. Yeah. Sometimes I do that too. So that's good. That's good. This is going to be an introduction, and I'll have a disclaimer here shortly. So please keep that in mind. So for those of you who haven't done test-driven development, it may sound like it's a buzzword. It sounds pretty cool. Test-driven development. You've got testing in there. You're driven. You're doing something. You're not just hanging out and doing whatever you feel like, and it's development. So it kind of sounds like a buzzword, but it's really not. So it's a very simple process. First you write your test, then you write your code, and then that's just what you keep doing in kind of a loop process, and then you profit, right? So we'll talk about details of how that actually works. So, all right, here's the disclaimer. I'm glad I didn't put this in a cursive font because that would just be creepy. But I do have a disclaimer, a confession to make. I'm not an expert on this. I started working with Ruby and Rails and TDD about a year ago, about a year and a half ago. Didn't really at that time understand what TDD was. Started using it, started getting better at it, and getting worse at it, and getting better. So I'm not claiming to be an expert. I'm kind of a newbie or a poser or a wannabe or whatever you want to call me. Just anyway. So feel free to, those of you who have been doing test-driven development to contribute to the conversation. Okay, so let's see, it's 7:19, so I better be done shortly after 8. This is supposed to be 45 minutes for those of you keeping score at home. So I thought it'd be good up front to give us a focus on what we're going to talk about here. And I'm not going to go through all these slides. Can everybody read this okay? Okay, good. So a little bit of the kind of the who, what, where, when, why, and how. Well, I guess I will go through these a little bit. So who benefits from it? Not just you. This is the point I've forgotten to make when I've kind of run through these slides before. But we will go through this same slide at the end of the presentation as a review instead of a preview, just so we're sure that we covered all these things. We'll talk about 2 different kinds of tests, why you put them in your source repository, when you use it, and why it's a good thing, why we weren't taught to do this. That's one of the weird things about it, is that you think, well, if this is such a great deal, why didn't they teach me this when I took classes on how to code? And how it really works. So we'll have some slides, and we'll also have some examples. So briefly about me, I think my job title is Senior Analyst DBA at High Touch Technologies here in Wichita. I've spent about 18 years in IT, mostly around data, databases. The current products I use right now are mostly Postgres, an open source database. I really like Postgres. Not going to get into a flame war with anybody, but I'll tell you, I've used it, and I actually didn't start using it until I came to High Touch. I've used Oracle and SQL Server as well. Pentaho is a tool that I use for ETL, extract, transform, load. It's an open source tool. And MicroStrategy for BI, obviously that's not open source. And as I mentioned before, I've been using Ruby on Rails for, well, about 1.5 years, and that's my email address there at the bottom of the slide. So now, I know a lot of you are web developers who are probably more into JavaScript and things like that than maybe Ruby and Ruby on Rails, but other platforms have tools a lot like this. In particular, for those of you who do a lot of JavaScript, there's a tool called Jasmine that when I looked at it, looked almost like a copy of RSpec. It had a lot of the same syntax, a lot of the same ideas. So want to let you know about that. And we'll talk about Rubocop in a little bit. Okay, so I started out thinking, how could I illustrate test-driven development? I thought, well, a lot of people I think here work as, independent consultants or contract programmers maybe some of the time. So if you have had an engagement from hell where, the guy the big boss, the one who has the money to spend, he's furious, okay. All right, and of course the original programmer's gone, so you don't have somebody you can bounce ideas off of or get a really good feel for how things were supposed to work. And then the previous consultant left on bad terms last week, but he got paid. So now you're not going to get paid until you fix everything. Okay. And you have the source code, but it doesn't really help. All right. So that's kind of the idea. Now, I don't know if I fully fleshed out this whole scenario in the code examples, but that was kind of where the idea started. So, so what is this application? Well, okay. Indulge me a little bit. I thought, wouldn't it be cool to have a calculator and a horoscope? Wouldn't it be cool if it ran on the command line? So,
make sure you're going to get paid.
Yeah, exactly, exactly. So, kind of just a very contrived example to illustrate the points. So the unhelpful source code. Now, I'm not going to spend a lot of time looking at this, but we'll go ahead and it's called bad. Now, can everybody kind of read that? Is that a little bit small? How is that, Seth?
The size of it?
It's okay. All right. So, I'm sorry? It's okay? Okay. All right. So, in this contrived example, the idea was that this was created in 1999 by somebody. It just so happens to use current Ruby syntax. Not sure how that happened. But so here's what we have. We've got a lot of comments, some put S's, you know, to put string output to the console. We've got some if-thens. Then we've got some code down here that I guess this guy, you know, he says, getting tired and who wants to be a millionaire's on soon, so we'll do this tomorrow. And he just left it all commented out. So down here, told the boss we had to upgrade our modem to 14.4 to do this. What do we have? Boss is complaining about having to read around the curly brackets, told him that's what web services do. And just kind of, it's a big blob. And you know, like this comment, now that Y2K is over, it's safe to divide. Not sure. Anyway, not very helpful. And initially, when I started running through this, I thought we would, you know, illustrate, you know, why the code sometimes works and sometimes it doesn't work. But we really don't have time to do that and stay within our time frame goal. So, you know, even if you have source code, it's not always helpful. And we'll see a specific example later of how it's really not helpful at all. So what are we going to do? Well, we'll just do a rewrite, and that's where we'll get into kind of the iterative process of test-driven development. So yes, we will use that newfangled TDD. Okay, so what's the process of test-driven development? Well, as I mentioned before, it's an iterative process. If you're adding a feature, what do? Well, when you start out, you don't have the feature, right? That's what you're adding. So you should be able to figure out a way to write a test that says, I don't have the feature. You know, your test may come back with a failure as simple as function does not exist. So, and that's okay. You want your test to fail at first. That's the way you know that you're testing something. Okay? If you write your test and it passes and you haven't written any code yet, what are you testing, okay? It took me a while to figure that, to understand that's what people meant, but yeah, that's what it means. So you write that test, you watch it fail, then you write the smallest amount of code that it takes to make that test pass, okay? Then you're done. Okay, if maybe that feature is a big feature. Maybe it's, you know, you think I'm going to end up writing a couple hundred lines of code. Do I want to write all of my tests for all of that feature up front? No. You know, bite it off in smaller chunks. And that's where you kind of have to change your thinking a little bit. You know, I kind of find myself when I develop the usual way, which I still do too much, that, you know, I'll start to kind of get on a roll and then I'll get sidetracked and then get confused. This is a much more disciplined process, but you as a developer are in charge of this. You're the person who decides what tests you think are most appropriate. So even though it's a process, it's one that puts you in the driver's seat. So you make that test pass. Then if you've got more parts of the feature to write, then you create another failing test, a small test. And then you write the amount of code you need to make that test pass. And you keep iterating like that until you're done. Okay?
Just remember, do as little work as possible.
Yeah, right. The less code, the fewer lines of code you have, hopefully, the fewer potential bugs you have.
And if you are highly inspired and want to race ahead, do that in a separate branch and then backport things later as you develop your tests.
Right, yeah. And that's another thing, and I'll mention it now just so I don't forget about it. I think a common practice is only commit your code when your tests pass, when all of your tests pass. Okay. Now, the process of test-driven development to fix a bug is almost identical. And that's part of what's so cool about it is that, okay, you have a bug. Obviously, so your program doesn't do something correctly. Well, you need to be able to write a test to expose that problem. Okay, so you create the smallest test that illustrates that bug, that shows that it's failing. Now, if it's a big, complicated bug that has a lot of complex interactions and there are about 4 or 5 different things you need to fix to make it work correctly, then I would suggest break that down again, like you would for a big feature. But if it's a simple bug, just create a small, simple test that illustrates that the bug or that the test fails, that illustrates the bug. Then you write the smallest amount of code to fix the bug. Make the test pass. And then you're done when the bug is fixed. Okay, so very, very similar. Adding a feature, create the small test, create the small code, iterate until you're done. To fix a bug, create the small test, create the small code, and then when it's the bug is fixed, you're done. So iteration is definitely your friend. Okay, before we get into test-driven development done wrong, let's go through a little bit of an example here. So one thing that might seem a little weird about this is that I'm saying write your test first. Well, what if you don't really know what it is you want to test at all? You might have an idea of some of the things that your program's going to do, but you're not really sure exactly, what's the result going to be. So RSpec, and I looked, and Jasmine has the same keyword called pending. That's a nice way for you to say, I know I need to test something, and I know, but I'm not really sure exactly how to write that test. So one of the nice things about test-driven development is that it's popular enough that if you're running into a situation that seems a little bit odd, somebody else has probably run into that as well. So, in this situation here is, I don't know how I should write my test. So I'm just going to kind of put a placeholder here to say, yeah, I'll write that later. Now, you can run your tests, and here we have everything coming back in yellow, saying, okay, this isn't bad, red is bad. This isn't good, green is good. We just don't know yet, and that's just some colorizing. And I'm using Vim for this, but pretty much I think every coding editor has a way of doing this. So when I saw Seth's mad Vim skills, I said, I got to do me some of that. So I've written those tests, and let's see. Oh, did I? Oh, it doesn't warn me, does it? Command T. Oh, that's dangerous. I always get a warning. Okay. I'll try not to do that again. Okay. No, that's not right. Yeah. Yeah. Well, in Terminal, it warns you, or it warns me. I don't. I feel so.
Sounds like we needed Chuck Norris joke.
Making me feel so pedestrian here. One more. Was that about what it was? Okay. All right. All right. Whew. Okay. So, let's see. So that was my spec, and okay. Command W bad. Control W good. Okay. Control W J good. Okay. Okay. So I ran those tests that are all pending, and on the bottom that's my code. Okay. I really haven't done anything yet. I've just defined some classes, I don't know if those pending tests might fail if I didn't have those classes defined, but they're just empty classes. There's really nothing there. Okay. So when I was practicing this, I had the tests on the left and the code on the right. Since we don't really have enough room for that, I'm going to try to keep my tests on the top and the code on the bottom window. And I'll try to avoid Command W. So let's create a happy test. Okay, so down here on this calculator class, everything is still pending, but on this command reader, we're saying it allows a valid command, and you're going to enjoy finding out just how fast 5 seconds is when you're doing TDD. So let's, and then I'll bring the code here to the bottom. Okay, so here's my command reader class. Now, I use this pattern of kind of already writing the code there, but commenting out to simulate that I haven't written it yet. I don't know if you buy that or not, but so this is our first real test. The command reader allows a valid command. All right, well, let's run that guy. And whoops. Oh, there we go. Oh, remember that 5-second sleep? Okay, yeah. So okay, we had a failure. It's saying wrong number of arguments, 2 for 0, which means that it doesn't see that I have an initializer or a constructor there. That initialize method is commented out, so the default initialize method in Ruby takes no arguments, and that's probably the way it is in most languages. So, okay, I'm really sweating out avoiding Command W. Okay, so we'll go ahead and uncomment that out. All right, now let's just run this test by itself. How about those royals?
Yes.
Oh, okay. All right. So what happened here? Okay. Oh, that's right. That's right. We're not done yet. So I created a command with the word add, and I'm saying I'm expecting the command to equal ADX. Okay, ADX is not the same as add, obviously, so that's why it failed. So it expected ADX, but it got add. Now let's say that you're jittery because you drank too much coffee or soda pop or something, and now you're going to fix it, but oh, I am jittery. You did it wrong. Okay, and you got this test that takes 5 seconds. Okay, right? That's just going to drive you nuts. That's why people say make your tests fast. Okay, you want it to come back almost immediately. So we'll take that sleep out, and now we'll run it, and boom, it comes back almost instantaneously. So now if I fix it, I'm going to say, well, no, I really should expect the command to be add. Okay, and that time I hit the lowercase t, which ran everything. Might be a little hard to see, but up there in the upper left corner, there's a green dot. That means that's the test that passed. And again, this is just the way that it's set up to work here with Vim. I can run it by itself. That ran by itself, and then it's succeeded. So you really want your test to be fast. You want to think milliseconds, not seconds, because you'll just, you'll get distracted. So that's our happy test. So okay, the next thing is an unhappy test. What do we mean by unhappy test? Well, you have happy cases where you have good input, and then you have unhappy cases where you get bad input, and you don't want your program to be just taking that bad input and creating bad output. You want it to tell you that, hey, this is bad. So this is our next test, the unhappy case where it rejects an invalid command, and on the bottom here, I'm going to go ahead and bring up the code. So again, I've got some lines commented out that are going to make this work. But let's go ahead and run that unhappy case. We're expecting that if we give it a command of bogus, that it's going to say, hey, this is an error. This is bad. Okay, so now, it's kind of a double negative here. I expected the code to tell me that there was an error. But it didn't tell me there was an error, so the test failed. So the test is giving me an error, okay? You always want all your tests to pass. Seeing this stuff doesn't mean, oh, hey, it raised an error. Good. No, the code was, this main code was supposed to raise an error, and it didn't, so the test failed. So we'll go ahead and come down here now, and all we're really doing is saying I have this list of commands, add, sub, mult, div for divide, x for and on horoscope, and I've got this if block that just says, hey, if you're not one of those commands, then raise an error. Okay, so let's try running it again. Okay. So that time it passed, and if we run all of our tests, now we got two little green dots up there in the upper left corner, so we're making progress. By the way, some of you who have been using test-driven development, and can anybody tell me why this particular test is not that fantastic?
Is it because it's catching like an engineer error?
Yes. Yeah. Yeah, I could say, hey, in my initialize, I could say x equals 1 divided by 0, right? And that's going to, it still works, right? Well, the test passes, so I guess, if we're putting on our testing hat, we say, well, that's okay. But then if we try to put this code into production, then no, that's not good, right? So, and then also, but also, the fact that we have the happy case and the unhappy case together means that now that I have that that divide by 0 error, now my happy case test is going to fail, right? So, oops. So let's go ahead and run all of them, and ooh, say what? What? What's that? Okay, all right. Don't hurt yourself. Okay, so, well, that's quite odd, actually, that it would succeed. Okay. All right. Well, we'll leave that as an unsolved mystery. Then I think the last thing I want to show before I get back to some of the slides, and we'll come back here, but I want to break it out a little bit, is that there's a tool in the Ruby world called Rubocop, and ooh, I got too many. There we go. Okay, and Rubocop is a syntax checker. It's a style checker. Now, if your code doesn't, if you have syntax errors, Rubocop will figure that out, because when it runs, it actually figures out, it's actually parsing your syntax, but it also makes style suggestions. So, like, I have this code where, this is valid Ruby code, but you'll notice here my my indentation is goofy, which is a little confusing. I also have this if not, and Ruby has a more kind of nice way of saying that. So this time when I ran a command, I was using Rubocop, and it's saying you have these offenses. Now, if you've watched the movie Robocop, that's the inspiration for the name Rubocop. And actually on the GitHub page, the README starts out with the quote, "Role models are important." That's Officer Alex Murphy, who became Robocop. It's just awesome. So I love that movie. So here Ruby or Rubocop is telling me that there are a lot of ways I could make my syntax work better. The command array of strings, it's saying now the Ruby-ish way of doing that is to use %w and then wrap them in parentheses, and then you don't have to worry about the quote symbols. The if statement is awkward, and it prefers that you use fail instead of raise to signal exceptions. Now, you might get into an argument with another developer who says, well, I think you should use raise instead of fail. Okay. Some of those things are pretty subjective, but what's really nice about a tool like this is that if you make it part of your development process as a team, then the team's code all starts to look pretty similar and more comfortable and more familiar. You don't feel like, you know, as when you move from one module to another, oh my gosh, this is totally different stuff. So that's what Rubocop can do for you. And let me just
or even more pathological case from one part of a given module to another as it's been through 4 different developments.
Yeah. So this is what Rubocop wanted me to do with that commands array. This is how it wanted me to say, hey, we're going to fail with the message bad command unless the command that you gave me is in my list. So, and then also fix the indentation. So, and we'll get into the iterative process here in a minute. Well,
is that a separate file, or did you actually have the Rubocop images?
This is a separate file. Now, there is, Rubocop has an option, I think, to go in and try to automatically fix things for you. I haven't done that yet. Yeah, exactly. So stay out of trouble. He says that too. One thing that it really helped, one reason I really liked it when I started using it is that it told me about ways to write Ruby that I wasn't familiar with. And I was learning Ruby as I was using it. So that was, so I really like it, obviously. So let's talk a little bit about how to do TDD wrong. Okay, I think I've done all of these things, so I know. So kitchen sink classes and methods. So you know these are like your monster methods, your 100-line, 200-line, 300-line methods that just are impossible to break down if you write these things and you try to figure out where the bug is. You know. Well, what do you do sometimes? You know, you put a message like right in the middle of it, and then you say, okay, did I get to that message? And okay, no, I didn't. Okay, it's in this app. You know, it's like you bisect it, right? I was doing some of that today. I'm ashamed to admit, but those are really hard to test. You know, big classes and big methods because they're unwieldy. And kitchen sink tests. Now, I was writing some tests today, and they were about 10 or 15 lines, and they were really too long. I know there's a better way to do them, but the reason you want your test to be short and simple is that if you have a test and it fails, and with your code, then you start to wonder if your tests are getting pretty big. Okay, is my problem in my code, or is it in my test? And then it gets really confusing. So you want your tests to be very short and simple, okay? And slow tests, we talked about that, you know, tests that just drive you crazy after a while. So doing it the right way. Well, there's a guy named Gary Bernhardt who's got some videos on the internet, and he's made some presentations. He talks about a concept of the functional core and the imperative shell. And I'm going to talk about kind of what my impression of that is. It's probably not exactly the same as what he meant, but it's close. And hopefully it's useful. Use mostly unit tests with integration tests as needed. We'll talk about that in a minute. And obviously we want our fast tests. We don't want our tests to interrupt our thought. So now some of this might be a little bit small, but you can think that this is about functional core and imperative shell. So most of you, I think, write web applications or applications that are internet enabled. So you have kind of two parts of that application. You have a lot of it is interacting with the outside world. You have end users that I've got there on the left. They could be using browsers or mobile apps, or they could be automated systems running batch scripts or something, interacting with your application, providing I/O. Then your application probably also interacts with the database if you need to store anything persistently, and that's the database there at the bottom. And then over there on the right, we have web services, other boxes that are on the internet available to provide services that you want to leverage. So your application has those interactions. Another part of your application is more internal, okay, where you're writing the code that's calling your code, and you're not reaching out to the outside world. You've got this internal stuff. And the idea behind the functional core imperative shell sort of paradigm, I guess, is that you want that core to be not as large as possible, but you want the percentage of your application to be as much core as you can make it. Because that shell part is relying on other things. And it's like it's relying on the database, or it's relying on those web services, it's relying on input, output. And that makes it more complicated. You have those interactions. So, but if you can just make your application as much just kind of data in, data out, or values in, values out, then those kinds of functions, those kinds of methods are a lot easier to test.
Think in terms of browser compatibility. Yeah. You have too much stuff in the shell in the different browsers, which makes it a huge pain. Whereas ideally, that could all be handled in the core.
Yeah, you don't want to be spending all your time testing different browsers. You don't want to be creating a browser. So yeah, good point. So, and this idea of the core and the shell leads to what I want to talk about with unit testing versus integration testing. So again, thinking of your application as kind of this big circle of stuff with the shell at the outer layer and the core in the inner layer. When you run a unit test, you're testing a very, kind of just one method, data in, data out, ideally. And so you're just testing a very small piece of your core, and that's sort of what that red loop is supposed to represent, is I'm just testing one method that's inside my application. So an integration test, on the other hand, could be 1 or 2 or 3 parts of the outside world or parts of your program all kind of interacting with each other. And so maybe you start out with end user input that goes into your application, and then your application makes a web services call. And then that comes back to another method in your application, which then has to go retrieve something from the database or write something to the database. And then that goes to another method, and then it comes back to the end user. That's a big honkin' integration test. And it kind of looks like the outline of a moose. But those can have value as kind of as a sort of a warm fuzzy. It all plays nice together. But those could be a bear to debug. Right? So that's why a lot of people say focus on your unit testing, get that right, then all your pieces should fit together, all the pieces of your application should fit together properly, and so ideally you don't need to do as much of this integration testing, which takes, you could see testing something like that would take a lot longer to set up too, and just be a more complicated test. So in the examples that we use, that we'll see here in a minute, we'll use mostly just unit tests. Okay, So let's go back here, and I just want to give you an idea of what it's like to do the what it's like to iterate with your tests. So this is called, let's see, we'll put the test on the top. It's on the top, right? Yeah. And then the code on the bottom. Whoops. What did I do? Oh, it's already there. Okay. So here's, now this again is a little bit of a contrived example, but we haven't actually had our calculator do anything, right? So we're going to say, hey, it adds two numbers. So if I give it add with 3 and 4, I expect I should get 7 back. Well, do I? No, obviously no, I don't. So that test fails. Why did it fail? Well, it failed because I didn't write the method. So now let's come down here, and I need to uncomment this perform method because I didn't have that method. Actually, well, let me see if I can do one thing here. Let's put it back to the way it was, and let's see. I don't think that's gonna. I'm sorry. I was gonna see if I could scroll back. That time it failed because the method doesn't exist. Okay. So now, well, you're gonna have to take this on faith. Now we have the perform method, and we run it, and oh, that's a different error. You don't believe me. Okay. So, but I have the perform method. Okay. Now I will go ahead and define my add method. And one of the things about Ruby is that it has this send method that allows you to, the first parameter to that is your method name. So it's kind of like meta programming. So when I run send and my command is add, it's going to look for this method called add, and it will find it. And my test will pass. So there, we're green. Okay. So now I wrote my add method. Okay, now let's write subtract. Okay. Well, before we write the method, let's write the test. So I expect that when I subtract 3 from 5, I should get 2. Now, does it pass? No, I don't have that method. So let's come down here, and this is, you know, not very picturesque code, but we'll uncomment that. Now we have the method, and now I'm green. Okay, so and I can do the same thing now with multiply. I'm going to do something a little bit different. I'm going to go ahead and uncomment it at both the test and the code. But remember what I said about making sure that your tests fail? Okay. Well, I haven't really exactly been doing that. But I can simulate that by saying, oh, you know what? I'm going to take that result and I'm just going to add 1 to it. You know, A times B plus 1. My test still expects it to be the product, 5 times 3 to be 15. But in my method now, I'm adding 1, so I'll get 16. So now I run it, and I see the failure, and Seth, do you know, is there a way for me to scroll up on that?
Run the test.
Okay.
And see if you can do slide it up on the trackpad. I don't know if
No, I don't see that. Oh, there you go.
Yeah, just 2 fingers.
Oh, okay, side by side. Okay, so if you scroll back up, because I'm not going to do it right. There you go. Okay, so it expected 15 and it got 16 back. So we made our test fail. Okay, so oh, that's like.
So you're going to make that output less verbose. I mean, most of that is verbiage.
Yeah, it's your stack trace, which, you know, Ruby has big stack traces. I think there's probably I know there is a way to do it. This
RSpec is pretty.
yeah.
I haven't
and if I run all of my tests, I get shorter errors with the way and that's just the way I've configured those commands, those shortcuts, keyboard shortcuts. So yeah, this is a little bit better as far as more compact, a more compact error message. So that gives you an idea of the way you can iteratively, create the test, then write the code, then create the test, then write the code with, finishing each loop when the test passes. So keys to writing fast tests. Number one is you can stub out those dependencies. So one of the things you can do in your testing is instead of actually interacting with the database and sort of simulating it with test data, you can kind of fake it. Mocks and stubs are two of the words that people use, and I'm not going to get into those too much, but if you think of like your method is going to make a call to the database, but it's always going to expect to get the same thing back. You want the database to have a row in there that has user John Doe. Okay, well, you might be able to write a test that just simulates that. You sort of fake that method. And so that you're not actually interacting with the database, and that can be really advantageous, especially when you're writing a lot of tests. Like the application I'm working on right now has, I think, over 400 tests on it. And hide my head in shame, it takes over half a minute to run on the best day, right? It's a monster, yeah. So, and part of the reason why it takes so long is because I'm interacting with the database. I have to set all that stuff up. And if I could, go back in time, I would change that, but it's kind of the way it is. But when you get started, look at how to do mocks and stubs. And because not only do they help with speed, but they can also help where you want to simulate reaching out to a web service, so that so that your tests aren't dependent like on that website being up or always giving you the same result.
Another benefit that I think is worth pointing out about mocks and stubs is like if you have, even if it's like not a web service, but it's one of your own services or something, you can have, by mocking out what that service will return, if there's a failure, you know that the failure is in the system you're currently testing.
Right.
And it's not that one of its dependencies failed.
Right.
So it's like it makes it easy to isolate.
Yeah, excellent point. Of course, you want your mocks and stubs to be simple, because then if you make them complicated, then you're not sure if it's the problems in your mocks or your stubs, or yeah. Okay, so it's a little after 8 o'clock. I'll blitz through the rest of this. So just briefly want to talk about the test-driven developments. You get real working documentation. It scales with your project. It's objective proof that your code works, and I'll claim it leads to better collaboration. So real documentation. Have you ever seen code like this? Now the comment's a little bit dark, but the comment says add sales tax to the total. The code says total equals total minus sales tax. You ever seen that? Yeah, and you wrote it. Damn. So comments are nice, but comments don't always tell you the truth, obviously. There's no rule that says they have to tell you the truth. But when you have tests and those tests pass, then it's real and it works, and it shows you something. Now, it doesn't necessarily guarantee that everything works, of course, but it's more real than just a comment.
And it could be that that comment was telling the truth. You don't know that.
Yeah.
Hey, maybe somebody made sales tax a negative number.
Yeah. Wow. I didn't even.
I've never seen that.
So scalability. What I'm just going to say is test-driven development. You can use it with a project at any scale. If you have a small project, you'll have a small number of small tests. If you have a big project, you'll have a big number of tests, but you want to keep those tests small, and it can work. It's not something like, okay, well, I'm just going to use a flat file, and then when my project gets big, I have to go use a database. I can use this this method regardless of my project scale. And I've seen it suggested that you might have about a 1.4 to 1 test to code line ratio. It depends, but that.
Consider the ratio of time and spend bugging to time spent coding. 1.4 to 1, or multiplying your coding time by 2.5. That's quite a win.
Yeah. Yeah. So have you ever been in this situation? Yeah, there was a guy who tested that 2 years ago, and he said everything worked, but he's gone now. And we've made lots of changes since then, so we think it works. We're not really sure, but we haven't heard any complaints. Well, I hate being in that situation where it's like I feel like I'm on quicksand. But the nice thing about test-driven development is that your tests stay with your code in your source repository. So you know that what you have tested works if you make sure that all your tests pass each time you commit. Okay, so and then better collaboration. Okay, I'm gonna say something here. I think a lot of people believe in what I call the magic bottoms theory of IT education, which is, if you just sit down with the code for a while, you'll figure it out. You're smart, right? As if the process of sitting down in a chair is going to kind of activate a brain-to-bottom connection that is going to magically, okay, now I can figure all this out. And it's even better if you can sit down in the same chair as the last guy who worked on that, because then the message that transferred from his bottom sitting into that chair is just it's still in the chair. You need to sit down on it to pull that knowledge back out, and then you'll get it, right? Okay, no.
Sounds like you're pulling code out.
Never mind. No, we'll leave it there. So, instead of saying, well, you just sit down with the code and you'll figure it out, it's a lot better to have those tests. That will help you figure out what the code actually does, because it actually runs the code. Okay. So why don't I like test-driven development? Well, it's weird. It's slow. It works just fine. Well, all right. Get your tech vibe on. Seth is totally stoked to get his tech vibe on, right? And there are some tools and some processes that are unfamiliar to us at first, but now we're very familiar with them, and we can't imagine not using them. So, so that's what I'll say there. What about it slows me down? Well, yeah, it does require some upfront time investment, but it sharpens what you're doing. It makes you think about what you're doing. It focuses your development, and it encourages you to program in smaller, more manageable pieces. Okay, what if I think traditional coding works fine? Well, it can still work, but with test-driven development, you get faster feedback. You see that method fail when you're building it, not when you throw it over the wall to somebody else who comes back with you and tells you that it had the problem. And then
or years later when you get them by a 0 day.
Yeah. So and the last point there, traditional coding was forced by limits that no longer exist. And this will get to that point where, why haven't we been using this? Well, in the old days, people used to have to punch holes in cards, put their cards together, hand them to the computer operator, and then go back to the computer center the next day to get their output. Okay, well, you're not going to do test-driven development in that kind of environment. Test-driven development is immediate feedback, right? It's, testing things right now. We just couldn't, well, I'm not that old. So, but it got better, right? We had code that we could compile for ourselves, but when we have things like make files and the compiled code is different than the source code, then that's another limitation that slows us down because we have this build process. Well, with a lot of the scripting languages, that just goes away. You know, we don't have to spend time building our code. We can be much more interactive with the test-driven process. Okay, so we're winding down here. Just go through the points to see if I actually covered them. Who benefits? And I think again I didn't quite cover this, but test-driven development can be a good way to communicate with your maybe not with your end users, but with a project manager maybe, where you say, well, I have these tests, it's unit tested. I mean, that's a good answer to have, as opposed to just, well, I've been working on it. It gives you more of a tangible progress that you can share with other people. We talked about unit and integration tests. I think we talked about why you put them in your source repository. Your tests are living with your code. They have a symbiotic relationship, so that's why you put them in your source repository. Use it for both developing new features and fixing bugs. Why it's better. I think we saw some reasons why. Why you weren't necessarily taught this, or probably weren't taught this when you first learned how to code, and how it really works in practice. And I got a few references here. There's a wiki article about unit testing that I thought did a pretty good job of explaining it. That's the Jasmine homepage. It leads to a GitHub page, but it also has like some other links on it. If you'd like to use this for JavaScript, then those are the pages for RSpec and Rubocop. And then the last link is the Gary Bernhardt page. It's got this website called Destroy All Software, which is really good, but you have to pay for his videos. But they're pretty good. So I'm happy with the ones I've downloaded. So put that on there as well. Any questions? Yes.
So with regards to keeping your tests small, if you weren't satisfied with one test of multiplication and you wanted to include more tests and like edge cases and stuff like that, would it be appropriate to put those in the same test, or would you write separate tests for every case?
The recommendation is that if possible, you just test one thing. Now you can write a test in RSpec where you say you have multiple lines that say expect, expect, expect. But if you can just like the example I was thinking about with multiplication is, what if in my main method, I converted everything to absolute value? Well, then I'd have a method that works for positive numbers, but not for negative numbers, at least when I multiply a positive by a negative. So I would probably want to write another test to say, okay, not only does it multiply two positive numbers, but it can also do negative numbers, and just treat that as a separate test. So, and sometimes that distinction is a little more obvious, where you have the happy case and the unhappy case, and you say, well, I want to test the happy case. It runs to completion and it gives me the result I expect. And then I also want to test the unhappy case separately, where it's going to tell me fairly quickly, hopefully, that there's a problem. So I would keep them short and try to just put one expect in there. Now I was violating that today because I was testing some controller methods in Rails, and I was saying, okay, I expect to get a return code. It's like an HTTP success code, like a 204, I think is what I was looking for. And then I was expecting also in the database to get the results I was expecting. So I was expecting both the user to get the message, yeah, it was good, and then also in the database I was expecting the end results to be correct.
You can also kind of organize your tests so that multiple scenarios have a common setup using like before blocks. So you can say before each test, do these two things. Otherwise, you could be testing multiple scenarios, but that all have the same setup code, so then you're repeating that code. So in RSpec and pretty much every testing framework gives you that ability.
Yeah, and it uses the keyword before, which that way you can have a common setup. See, yeah, exactly. Other questions? Yes.
So in your reading, and or your experience, is there an ideal test coverage, like percentage, like what amount you should, when you say yes,
Yeah.
we're covered?
I think one of the really nice things about test-driven development is that it's an iterative process. So it's easy to say, well, just test what you need. Well, how do you know what you need? Well, kind of, go with something at first. Don't overdo it. You could think, like if I had a multiply method, I could say, well, what about multiplying two positive numbers? Okay, what about a negative number and a positive number? Okay, what about two negative numbers? I could think of all kinds of different ways to test that. But from what I've seen, like on GitHub with open source projects, they don't really test every conceivable case. It's more of a thought of, let's make sure we exercise the code and get to that happy case, and then we're done. And then maybe we also have the unhappy case. But the neat thing about it is that, you can start with something and say, okay, I think that's good. But then if you have bugs or issues come up, then you start writing more tests as you take care of those bugs. And then those tests are the ones you first wrote are still there, and you're building up this library to where it's if it's a large project, it's totally reasonable to have hundreds or even thousands of tests. But it's not like you have to write them all up front.
And this is helpful, but you may have other tests as well, like input fuzzing, which aren't exactly 5-line quick running every time you compile. So it's not necessarily going to cover all your test cases, but you can do something really simple to manage 95+% of your tests, then you're way ahead.
And like you said, we're writing web applications, you let your users drive your future tests. You and I might think, oh, we need to account for multiplying two negative numbers so the users never do that.
Right.
Or maybe they do start doing that one day, so then we can retest.
Right. Right. Yeah. And there's another sort of not a buzzword, but it's called behavior-driven development, where the idea is that you test from the outside in. What we were doing here was was testing from the inside out. We were taking those individual methods and unit testing them. A behavior-driven development is more like, okay, what might the user want to do? Okay, I'll write a test that will do that, and I'll iteratively write the code ultimately to make that test pass. There are people who have strong opinions about which is better, but I think it's, both approaches can be useful depending on what it is, the use case is.
Step 4 was profit, whoever gets paid faster.
Yes.
So the examples seem really obvious because they're really simple examples. How would you write a test for something that's maybe less trivial, like if you're trying to debug something graphical?
You would hire
Or like a layout output or something.
Yeah, something that's not as simple as just checking the return value or an internal variable.
That's a good point. That gets to, do you write test based for things that are obvious, like addition or built-in methods, where you kind of guarantee, what.
So if it's graphical, would that be testing, do I see something in a certain place on the screen?
Sure, yeah.
Yeah, honestly, I don't know how you would do that, other than if there are some tools
Yeah,
that simulate browsers.
Yeah, exactly. So there's a tool called Capybara, and that's something that's used in Ruby that basically has a headless browser that runs behind the scenes and loads your page into the browser. You can test for, you have like DOM, not manipulation, but you have access to the DOM. You can say, I'm expecting this element to be here, to have this text in it, things like that.
So that's good for web stuff,
Right.
What if you're not doing web stuff?
Well, it depends on your environment. There's probably a framework for it that'll test that kind of stuff.
Okay.
Well, and like another one for web, like to be even more complicated, there's Selenium is like a driver. Selenium is not a test framework, but like most test frameworks talk to Selenium, and like you have Selenium running on your machine, and when you run your test, you'll literally see it open like Firefox and click on things, and way, and like you script a whole, you like script a user interaction with the page and assert that everything happens the way you're expecting. And
That's like the example of ET.
right.
And that's copy bar.
That's what it's more like the outside. Yeah.
And this is helpful, but not a miracle cure. I think that's what you might be alluding is when you have code that has high cyclomatic complexity, or the number of possible paths through your flow, there is no easy answer there. So you'll hope you can cover as many paths as possible, but when you look at parsing libraries or compilers, it's impossible to test quote-unquote all code paths, so you cover as much as you can, but then still there are bugs later and later, so you hope your cyclomatic complexity is as low as possible, which is true in general, no matter how you're testing.
Yeah, Rubocop has a built-in checker on your cyclomatic complexity, and it's pretty sensitive, actually. It'll start complaining, I think, when it's more than 8, and it's very easy to get higher than 8.
Yes.
And cyclomatic complexity, I didn't know what it was until a couple months ago when Rubocop started complaining. It's kind of like the number of branches that your code could take. So you can think of it as if this, then this, else this, that increases your cyclomatic
Conditional
complexity.
statements, so is it like 1 for 1? So like if you had like 8 conditional statements, then it would start to say.
No, it's the number of paths.
If they're nested, if you get exponential.
Yeah,
Yeah, right. But
yeah, it's pretty easy. Like if you have just a couple of if statements to start getting pretty close to that limit.
Totally that guy today. So Ruby has RSpec, and it seems like that's a Ruby-like language for defining these tests. What would a test scenario look like in a language that doesn't have maybe a built-in framework for testing?
What language would that be?
Well, I don't know, like
First of all,
Whatever you want.
all has a lot of try-catch.
Making sure types are right.
Okay, so
Java has
let's say
JUnit.
C, for example.
Okay.
Let's say we're programming in C, we don't have
Okay.
access to the internet. And we want to do test-driven development. It's post-apocalyptic. I mean, is it as simple as just writing functions called test whatever?
Yeah, and at that point, you're basically making your own testing framework, and you could if your language didn't have one.
So that's basically what
The point of testing framework is to
Okay. Step 1 is leave and go somewhere where you do have internet. And then do a Google search. No, but really, I think so many people are using unit testing and test-driven development that there are tools out there.
Okay, so since you pulled that up, could you go ahead and click on the example? Because the language is still C, right?
Sure.
The unit is a lightweight system.
Okay. So it looks like it's if it's getting a bad result, it returns a -1, and then it. Oh, is it? Okay. Okay. Assert is where. Yeah.
So that's like Ruby's expect. Right?
Yeah. Assert, expect. Those are very similar, if not identical. Yeah. So yeah, I think for any fairly popular language, there's stuff out there, and a lot of them, I think, a lot of those products, like I said, Jasmine and RSpec look almost exactly alike. A lot of them use nearly the same kind of syntax, as similar as it could be, because you get the feeling that one guy was using one language and then he started using another language and wanted to have the same testing framework, so he wrote it. Or she.
Yeah, I'm just wondering, how do you test functions that do things like write to the database when you simply can't have that happen as a test? Do you need to write into your function like this is a test, don't do this part of the code? Because
I don't know about Ruby, but some languages they do this. Like Python, Django, for example, will do mock writes. not necessarily.
There's kind of there's a couple different ways you can approach that. You can, I mean, with like an integration test, you can just test that it returns to the database. You can have it actually go all the way right to the database, and then your test is then like accessing your ORM and then trying to go grab that record that you expect to be there. Or another thing you could do is like, normally if you're doing a database right, you would have an ORM or your model that is going to actually perform the write. You can stub out that class and overwrite the method that would normally perform that write to the database, and just make sure that that method received the information that it's supposed to.
So I didn't get to this, but I'm sorry.
Centralize that in the portal.
Right.
So I didn't get to this part of the code examples, but this is an example of mocking where I'm saying we're mocking a method or function called predict future. And so I'm saying I'm allowing the horoscope object to receive a method called predict future, and it will return, you will have an awesome day. And now what's a little kind of interesting about this is that I'm mocking something called predict future, but then my expectation is based on a method called predict. I didn't change the predict method. Predict calls predict future. But when I run it as a test, it calls the mocked method. It doesn't know it. But that's a way, like, and the idea behind this example was that, you know, your horoscope changes daily, right? So, but in your testing, you'd want to, regardless of what day it is, get predictable results back. So you could do something like that where whatever that method is that interacts with the database, you mock it here, and you say, well, this method is going to receive this message, but it's always going to return what looks like output from the database. Other discussion? Yes?
So one of the points that you made is that you should always make sure that your tests fail.
Yes.
And so you created a scenario where you force the test to fail. So it seemed like you were testing your test, right? Would it be appropriate to write it?
Yeah, yeah.
If so, where did you draw the line?
Well, the reason you always want to make sure that it fails is because if you don't see it fail, then you don't have any assurance that you're really testing, right? So if I write a test and it passes without me doing anything, then I haven't really tested anything. So I always want to see it fail, and yeah, there are kind of ways you can sort of fiddle with the method to force the failure, like we just added 1 to the result to force the failure of that test. But there's nothing, when you're writing your own tests, you know, you are in charge, you're driving the car. There's nothing that's going to force you to write a test that really tests anything. I mean, you could write a test that just returns true. And then, you know, that's why. But yeah, I wouldn't abstract at one level beyond that. Okay, all right. Okay, all right.
Maybe it's time for one more question.
Yeah. Yes.
How do you, or do you, test private methods?
In Ruby, there's a backdoor to private methods. That send method that I showed you earlier, where you can give it the name of the method and it will invoke it. That's the way you can call private methods. Now, if you were in another language, I don't know exactly how you would do it. That's how I would do it in Ruby.
Usually like reflection or some way to get to.
Yeah.
Or a lot of people say you just shouldn't even test the private methods because they're not part of the interface of your class.
Right.
So those internal implementations don't matter. All I care is when I put this in, I get this out, and I don't care how you do it. As long as all you put.
You're saying that ends justify means?
Yes.
I think he's saying with great power comes great responsibility.
You can also have a couple of methods similarly named, maybe throw an underscore on the end or something. Yeah, it is. It bounces to the private method.
Would you
Why not just say that
that's public?
No, you don't want to just make it public because then you may end up writing code depending on what should be private being public. And then if you were to go and say, okay, now
Just use a naming convention. Put an underscore at the beginning of the things that are public. And be adult and don't call those. I mean, right?
It's all concept titles.
Or you could do it that way.
My function's private, but.
Well, I want to go ahead and thank Rob
Thank
for
you.
doing this talk. I just want to point out, especially thank you for doing this talk because I think TDD is so important. As we pointed out, no matter what language you're working in, every major production language has testing frameworks, more than one, and different ways to do it. TDD is a philosophy, it's a lifestyle. It takes a long time to like really get into it and really learn it. But it's probably the most important thing that I think any software engineer could learn today. If I'm looking at candidates for a position and one knows TDD and one doesn't, I'm probably hiring the person that knows TDD, just because that's the direction that everything's going, and it's really, really important. So let me go ahead and just stop this. Feel free to hang out. We are